Okay, so hello everyone. Welcome to another Python class. And today we'll be going over classes. And so basically a class is one of the most important concepts in Python. Everything is basically almost a class. And since in order to have things that are classes, you need to be object oriented. And basically an object and Python, and as well as many other languages such as Java and C++, are all object-oriented. So, so let's just start by asking this question. So if we have a blackjack program, what would we need? We would need a deck of cards. So we need a deck of cards. And then we also need the dealer. And then as well as that, we need the players. And then we need the rules and like the scores, and there's a lot of things we need for a blackjack game. And so yeah, and we can all do that with classes. Classes help us make it simpler and also prevent us from making errors, while also giving everyone the ability to read the code better. And then if we wanted to, let's say, just code Facebook ourselves, we would need way more than this. But still, Facebook and basically anything you see on the web, at least most of it is based off of classes. So first of all, we need to figure out what a class is. A class is a way of aggregating similar data in functions. It's basically a class is basically like various code where in which various code is executed. And anything inside, let's say this is a class, anything inside here becomes methods of the class or attributes of a class. And an object that is constructed by this class is called an instance. So if we just take an example like a person, they have their name, for example, me, I'm Jaden. They have an age, they have a sex, they have height, they have weight, they have eye color. There's a lot of things a person has. And these would be the attributes of the person. And then we also have methods, such as they're speaking, they're walking, they're running, they're eating, they're listening to a Zoom class. These are all behaviors, which are the methods. So here's a very quick overview. This is confusing, but basically this is a class, and these are like the attributes, and then these are the methods. And then down here, this is an instance. And then we are changing the attributes. And then we have another class here. And we're just doing different things to it. So in order to understand classes, we need to first start off with an object. So an object is basically everything in Python. So if, for example, we wanted to use num equals 7, this would be an object. This object would have a type of integer. So type integer. And then that object would point to this. Now, only time you need to look at an object is if you want to make your own or modify the existing behaviors. So For example, if you wanted to create your own, let's say, a queue or something, then you might have to create your own thing depending on what language you're writing. Then you would have to you may have to look inside a class. So, so if this is an example class, we define it as people, and we have a name and age. And this init basically initializes it, where we have, it's called the constructor, as Python uses that to construct our instance of the object. And then all of them have to pass self in it if you want to use class people. And then you can set default attributes. And if they supply something in that space, then it will override the default attributes. Otherwise, it will just use the default attributes you set. So basically, our attributes in this case would be name and age. And then we have some methods. First one is initialization. Second one is call name. Third one is register course. And fourth one is raise salary. And each one of these do different things. So if we were to say P1 is equal to people of Kevin and 18, and then we do P1.call name, and then we do P1.register course and supply and programming, and then we do P1.raise salary 10,000. What would Python output? You guys answer that in the chat or unmute. Yeah, Jeremy, good job. That's correct. If so, we have my name is, and then Kevin, and that's what happens when you do call name. After we initialize people, P1 as a class people with name as Kevin and 18, when we do my name is, and then we take the name of it, since it's P1, the name of it, the attribute's name would be Kevin. And then same thing applies to the register course and raise salary. Okay, so what about this second case where we set P2 is equal to people, but we do not provide anything. And then we do P2.call name and then P2.register course Python. What would be outputted then? Please answer in the chat. Uh, Jeremy, that is incorrect. So this is where the default constructors come in. This is why we can do name equals no name and age equals 0. So based on that,
if we do not provide anything for the name, and as in this case we don't, name will be automatically set to no name. And if we don't provide anything for age, then we could set age to 0. And we basically just have name is no name instead of having anything. So then the output would be my name is colon no name, and then no name is registering for Python. Okay. Now there's another example of a class where we have a card, and this is the initialization. And then we set self.value to value and self.suit to suit, which is both are given. And then show card basically says what that card is. And then this and then we also have another class deck, which has two methods but no attributes. One is shuffle and one is deal card. And as of right now, they do nothing since all we have set in them is pass. So if we were to say, let's say like C1 equals card th 3 club, then we did C1 dot show card, we would get this card is a 3 of clubs. So then using that same logic, what would we if we did C2 is equal to card of K, comma spade, what would the output be if we wanted to show C2 if we did C2 dot show card? And please put your either unmute or put your response in the chat. Okay, it doesn't look like anyone's answering, but what this would do is just say C2 is equal to card of K. This card is a K of spades. Okay. Now, if I were to do this instead, if I set C1 is equal to card, but I do not supply any attributes, what would happen? Okay, Jeremy, let us see. Uh, It would be an error because there is no default values for this. So there is no initializer or constructor without anything there except the self. So Python cannot find it. So it cannot thus if and since it doesn't exist, it will throw an error. So usually in this is just convention. It's like it's called camel case where like class is basically like capitalized. It's not required, but it's usually better to capitalize it, especially if you have like a long word. And like for example, linked blocking deck. Linked. If you had this, it would be hard to tell exactly what type of data structure this was. This is made up, but it'd be hard to tell what type of data structure it is. However, if we did this, if we instead did linked blocking deck list with capitals, then this would provide a lot more information just by itself about what it is, just by itself about what type of data structure it is, if we were trying to code a data structure. And if you're confused about what pass does, pass, it just tells the Python interpreter to go on and do nothing. It's used when let's say you create like a skeleton of a code. Like for example, if you want to code, let's say, your own array, and you're coding it based off of a list. This is not a great example, but basically you could say like insert into the array. You would like append to the back or remove from the middle or something, and you would just have methods that declare that. But if before you put any code into them, if you do not put pass and you wanted to test a certain method, you will constantly get errors. So if you put pass there, then Python would just go on and ignore that part. And then one other thing is if there is it is possible if you for a class you to have this statement. This statement is just another way to comment, where it basically uh, explains what your class does. Like if we were to run this, and nothing would happen since this is just just a statement. Okay, so now if we're gonna talk about instance constructing, so we have a class named foo. And we initialize it with a value and a suite. And then we set certain attributes for it. And at the end we have pass, which and then if we just set f is equal to foo of a comma b. F is by itself is just an instance of the class foo. Oops. And nothing would happen as we're not doing anything to it. So if we want to access the member of an instance of a class, we need to use the dot method. And it's also able to access members of the class definition with a dot syntax. So, for example, in this foo class, we have a setX method. And basically what setX does is it sets self.x to whatever you pass into it. Now, if we were to instead we have bar, and we would print self.x, then it would just, in order to actually get x, if we just did print x, x by itself is undefined as there is nothing inside here, and there is no attribute that this bar method can access that is named x. But if we did self.x, it would check is there any attribute of foo that is x, that is x. And in this case, there is self.x. So then if we did self.x, we would be able to not cause any errors. And if we did bar, then we would be able to print out this value. Now, if we ran this code by itself, nothing would happen since we have not initialized any instances and we have not called bar. But then if we want to invoke the method, so if, for example, we have f is equal to foo. Now, by itself, f equals foo, there is nothing special about this class. It's just an empty class named foo that has two methods, setX and bar. Now, if we were to set x to 5, then all of a sudden set self.x for f. So f.x is equal to 5. And then if we wanted to do f.bar, then it would print out self.x, which we just initialized to 5. Now, now, question for you guys. What happens if before I set x, I do f.bar? Yes, Jeremy, you're correct, because there is no attribute of x. There's no attribute of x in foo. And thus, if we were to call f.bar before we set self.x, then we would cause an error, as the x attribute does not exist yet. And as the method shows above, the members of a Python class can change during runtime. So you don't have to declare everything beforehand. You can create things above slowly one at a time while you find the need to. For example, if you wanted to needed a y, you could do a set y instead of having to declare x and y up here. So if we run f.x, we would see that it just prints 5. But if we were to delete f.x through the del method and then try to run f.bar, we will get an error since f.bar said self.x does not exist anymore since we deleted it. And another useful thing about Python class is that we can change the effect the definition of foo class has during execution. So for example, we have foo.y, and we can set foo.y to 10. So basically what that means is in this specific line, we have inside our foo class defined up here, we have added an attribute that says y equals 10 once it is run. And if we set g is equal to foo, then we have g.y, which is by this first line here, it has been set to 10. And that's another just example of why we don't have to declare x equals blah, 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 y equals blah, blah, z equals blah, blah, blah. And it helps with declaration. So at the middle of all this is a dictionary. And the way you can access this dictionary is through the vars method. Vars, and then inside the middle, we put class name. Now, if we were to run vars of G, G is an instance of a class. It is not a class. So thus, if we were to run vars G, then they would return us nothing. But then if we did foo, then we would have a set x and a bar method. And then these other ones here are these plus the main and module are default attributes of the class that are given by Python itself. You do not need to declare it. And then we also have y here, which is 10, which we declare up here. And then if we did g dot set x is 5, and we looked at the vars g, then we would have, if we can do this and see that x is equal to 5. And in this method, if we had, let's say, 100 variables inside our thing, where we had like x, y, z, a, b, c, and a bunch, and then like, let's say like integers, x and stuff. If we have a lot of things, we can do vars of that instance, and by doing so, we will be able to get vars, be able to get everything, what everything is assigned to. Now, there are two ways to declare a class. One is was both are still usable, but one way was introduced in Python 2.2, which was introduced many, many years ago. And this one is probably a lot more simple for you. So basically, they're not that different apart. But the new style class is just a class that is built in as its base. Usually it's an object. And at the lower levels, the major difference between old and new classes is their type. Old classes were all instances. New classes are what return the same thing as x.class for your type. So if you put object here, it will return an object. If you put integer here, it will return an integer. And old and classic classes are disappearing now. So this is the old method where we just had this, and if you did this, it would make it a new method. And this is the new style where we can just make it define return objects. If we wanted to return an int, we can just return an int. If we wanted to return a string, we can make it return a string. But let's keep it object. And then we have, like, this is a new method. And another way you can do this is you can have these ats, which basically define what type of attribute this is. Like, for example, if you did at property, this would turn into a property attribute. If you did at egg.setter, this would turn into a property setter for egg, which is part of the spam with properties. So then if you were to just do sp.egg, since this sets egg for you, then you would it would automatically just set my egg since it initializes as my egg. And then if later on, if we wanted to, we can set sp.egg is equal to eggs with spam. Instead of having to do it the old way, which was defining a method and then having to do it that way, we can now just do set it equal to this. And then we can do sp.egg. Now there's the most important thing you need to know is that there's a lot of special methods in classes that are all already predefined, or at least some of them are. All of these begin with two underscores and end with two underscores, just like initialize, which is one of the as a special purpose. So like initialization is init, and this is the only one we've learned so far. And init can take arguments. For example, if we needed to hold For example, if we needed to have an attribute hold something or use that argument and print something. And this is called initialization. It is also called a constructor. Since this special powerful line of code, init, is what constructs every single instance of your object, of your class, which are all objects. So if without this, you're going to have to manually declare everything. With this you can just do foo equals foo high. Otherwise, you would have to do foo equals foo. And if we wanted to do, let's say in the initialization, we print prime time, that would be impossible. But if we wanted to set something, then we would have to do foo dot, let's say x is equal to 10. So, and then del is what happens when we want to destroy an object. When it's no longer being used, this is, for example, if we had this, and then we had two children nodes, two children objects, these two, and they point to those. And let's say this points to that, and this points to that. Now, if we were to delete this not that object, if we were to delete this node, this pointer, suddenly nothing is pointing to this anymore. And let's say we can then, if we are just not going to use it at all, for example, it is no longer in an arrays or anything, or it is not being pointed to by anything at all. Python is nice. It will erase it for you. And thus you're left with this, and it saves memory. And is then that same memory that was originally pointing to this can now be used for something else. For example, if we had a third thing that was also pointing to this, if we had third thing was doing that, then we would save some memory. And eventually this will help over time, especially if your device has memory restraints or the problem you're doing has memory restraints. This will help you in the long run. So there's two more instances. Two more constructors, enter and exit. These are the enter is a constructor and exit is a destructor as well. But then the only difference is that they're only executed when the class is created with them. If you never defined enter and exit, then nothing would happen to them. They're basically like a second way of initiate your instance of a class. And then, so str. str is one of the most important things you have in Python. If you ever want to print something out for like debugging purposes or outputting something for the user to see, str is your most important thing. So if there was no such thing as the str thing, just this would be similar to Java. It would say like a name. So example for this class, this would be constructor, structors, destructors, and then it would be just at some memory address. Let's say F7EK8R6. This would what if you just printed it out directly without a underscore underscore str underscore underscore method, then this would be what printed. For example, a string has a s2str method, but if you had a str method and it's originally say it has high, then it would actually print out high. But if you didn't, it would print out constructors, destructors at a memory address. And usually str cannot be run, but it is useful as it is all that method is always what is called when you want to print something or you want to get the string version of something through either print or do str and then put the thing inside. So if we have a class bar here and we have an initialization and then we have an str method and then we set bar is equal to bar of apple, and we printed bar. What would the output be? Yes, Jeremy, that is correct. If we ran it, it would just print apple. But then what happens if we deleted the str method? Okay, let us see. It would print the memory address of it as this is this basically tells you this is from in main. This is the object dot bar, the class dot bar. It is an object, and this at, and this is the memory in hexadecimal, which is why you need the underscore underscore str method, especially if you want to print your own classes. If you have that, it prints apple. Otherwise, it prints a memory address. Now, underscore underscore repr underscore underscore is very, very similar to str, but it is only executed if this is present and str is not. And then this is basically just another. This is used to return a representation of the object in string form, and usually it can be executed, and it to get back the original object. So if we ran this, it would be bar is under space apple is in quotes apple. But then if we define the str method, and we did this instead, it would just print. Oh, wait. If we did the print bar, we would get apple. But if we just did bar directly, then it would say bar is apple. That's the difference. One of them is if you just try doing in printing bar itself, it will use the RAPR method. If you try to print bar or to get the string value, then it would do the str. And then there's a set attributes method, which is set attr. This is a method of setting attributes in the class. So each class has a default set attribute method. And so, but you can override it. For example, if we had a class and we had, let's say, 10 elements inside of it, and we did not want the user to have the method to change the elements, then we can do this. We could override the set attributes method to prevent them from changing anything. And if we do that, if we try to change it, it will just say u dot x equals 9, and it will say nice try. And there was and u dot x, the u dot x will still not exist. It will since it will try to call the set attributes method and do what the set attribute method does, but then it will just say nice try. because that's all that is in the set attributes method since we overrid it. Okay, so there's also a get attributes method, which is similar, except it's called when we access a class member or attribute. For example, if we actually were able to set u.x is equals to 9 up here because we did not change the set attributes, then this get attributes method would be able to call it. Normally, the default value just returns the default simply returns the value. But if we wanted to prevent people from accessing them, then we can change the get attributes method so they can be maybe they're able to change it, but they're not able to see it. For example, here we do h.anything. We did not define it. So normally it would just return anything, but return you don't get to see anything is because we overwrote the get attributes method. And then finally, another thing we can do with attributes is a del attribute method. And the del attribute method is to delete an attribute. Now, if we wanted to prevent them from doing that, we can do p.x equals 9. And then if they try to del p.x, then it will just say print name cannot be deleted, and we will not actually delete the attribute as we have overrode the del attribute method. So then we have p.x, and it will still work if we ran this. Even despite us trying to delete p.x, it will still exist. Okay, question for you guys. So what method, which underscore is used to set an attribute? How do we set an attribute for an object? What special method would we use? Yes, that is correct. Now, what happens if we wanted to get the string value of an object? Yes, that's correct. And what dis constructors and destructors are only called if they are present in your class definition. There's one of each. Uh, that answer is enter and exit, as shown here. They're only executed if when the class is instantiated with them, where it means if you create an instance of the class and they are defined, then it will actually run it. It will actually use those. as well. Okay, and last question. Uh, how do we delete an attribute? How do we delete an object? Not delete an attribute, just delete the object, or in this or the instance of the object. Okay, that would be the del, where we just do delete. That's what the del is defined as. And by default, it just deletes it. But if we were to override it, we can prevent the deletion, where we could at least tell people that it got deleted. And then there are also other operations that Python uses. So for example, if you wanted to do addition, subtraction, multiplication, power, modulus, everything is defined there. And also, if you wanted to compare equality, that has to be defined there. These are all defined by in all the default classes that you use, like int and stuff. But if you're writing your own, you may need to define your own. If we were to do add a b and for a class fake number, and we had n is 5. So then basically what this would say is currently c dot n is 5, c dot n is 5. And then it becomes c dot n is 5, d dot n is 7. And so when we do c plus d, we would get the numbers, the two n attributes added together. So it would be 5 plus 7. So then what would you think would happen if I were to delete this, if I were to not define the add attribute, or sorry, add method? Okay, let us see. No, there would be an error as these are two custom classes and we never told them how we're supposed to add them together. So what Python does if there wasn't when we do C plus D is we see, okay, both of them are fake numbers. If they're fake number and fake number, we see if there's an add attribute. If there is not an add attribute, sorry, add method. If there's not an add method, Python does not know how you want to add it. You could say you want to add, but then it turns out you want the answer 2 by doing d b dot n minus a dot n. And Python does not know this. So then if you just did plus, Python would not know what you were trying to do and would throw an error. And the same should be for subtract and divide. if we did sub, then we would get d minus c, and it turns out, and this would give us -2, since we're calling d minus c, so a is d, b is c. So we're calling 5 minus 7, and that gives us -2. And then now, if now you also have to be careful when you're defining these. As so this part is so far everything is defined correctly for division. However, we are dividing an integer by a fake number, and that has not been defined. And if we were wanting to try to do that, Python does not know what to do. So remember to keep like your plus dot end. And then it's also possible to override all of Python's indexing and slicing operators. So normally the only place we can use this are strings and lists, but we can edit it. So we can do get item of self and index. And by using get item, we can redefine it such that it will actually do what we want. So for example, if we have f is equal to fake list and we have the get item defined, then all of a sudden f is of a, that is callable. If we did not have the get item, that would not be callable. But if we were to call it, it would just return index times 2. And since a is a string, it would just return AA. And then the same thing can be done with the set item method, where it's basically get item, except you're setting the item instead. So if, in this case, if I have fake list again, and if I set f of a is equal to gone LA, and we have f dot string. Now it will go through everything in fake list. And since we have set item to this, it will set self.string is now value. Index plus is now plus value. And basically what this does is it will go through our class fake list, and it'll see, okay, there's at memory address A. This is defined. So then I will print A is now gone LA. And then if I did f of B, then we would also have B is equal to 24. Now, the only issue with these methods of set item and get item is they're not particularly efficient. Like if I did this, if I did f dot string, it would only print B is now 24. It would completely ignore this line F A is gone LA. And which is why it's a fake list. It doesn't actually work like a list. Okay, just reiterating a couple of things before we end class. First thing is there is classes are probably the most important thing you'll use in Python. If any bigger project that you write, you'll probably have at least 2 or 3 classes, if not more. As that, it's like the reason why you use methods. So you don't have to write the same exact code over and over again. That's basically another reason why you use classes. And then a second thing is, so there are 2 parts of a class, attributes and methods. Now these do not, the attributes at least for sure do not have to be defined ahead of time. You can, while you are writing your code, you can suddenly realize, oh, I need to attribute X. Then I can add, just do that instance dot X is equal to something, or that class dot X is equal to something. And that would work without having to define it beforehand. As sometimes they're all written in different files, and you would have many, many, many files open because of that. And the third thing is you are able to write over some of the Python's like reserved operations. For example, like get item and set item. These are normally like predefined in default and they're usually reserved. But if Python is not as strict as some other programming languages, it allows you to modify these. And you can also like change like get attribute, set attribute, del attribute, and delete it. So and basically you can change how your code wants to behave, and this work and Python gives you a lot of flexibility on how you want to code things. Does anyone have any questions? Okay. If not, that will be all for today. Thank you for coming and hope to see you next week.